All right, so what are rocks? Rocks are a naturally occurring solid mixture of two or more minerals or organic matter. First, rocks are classified into three groups by how they're formed. This is very, very, very important. You have your three groups: igneous, sedimentary, and metamorphic, and the process that happened is what kind of rock that it is. So whatever process just happened is the type of rock you're looking at. After we have our three groups, you can break those groups down and you can categorize the rocks within there and classify them based on their composition and texture or grain size. And the rocks change over time through the rock cycle. So we have our three categories of rocks: igneous rocks, metamorphic rocks, and sedimentary rocks. And rocks can change from one type of rock to another by the processes that you're looking at on the screen. So you'll notice that any rock can become an igneous rock if it melts down, becomes magma, and then refreezes. And any rock can become a sedimentary rock if it is eroded and weathered into sediments, right? Weathering and erosion, and then gets compacted and cemented and becomes a sedimentary rock. And any rock can become a metamorphic rock if you apply enough heat and pressure. And heat and pressure like within the earth. There's one arrow that's missing. A sedimentary rock could melt, so there's an orange one missing. You could have a sedimentary rock melt and become an igneous rock. So essentially, it's not so much that a rock has to be one type of rock before becoming another one. It's just a matter of what type of process just happened. That determines what type of rock something is. So here's an example of what the rock cycle typically looks like. If you kind of start the rock cycle with igneous rock, magma comes up through the earth, and magma comes up and it flows out onto land and it hardens and cools, and then it erodes away and becomes sediment, which gets compacted, and it gets pushed down into the earth, and you can get metamorphic rock forming, and if it remelts, it'll come back up as igneous rock once again. All right, so igneous rocks always begin as magma, and magma can form when rock is heated, when pressure is released, or when the composition changes. Magma typically freezes between 700 degrees Celsius and 1250 degrees Celsius, and magma is a mixture of many minerals. So I would say that the most important thing here is basically if you heat rock up enough, it will melt, but not all magma melts at the same temperature and freezes at the same temperature, and we're going to talk about that. So depending on what that rock is made of, that will determine a little bit. Depending on what the rock is made of, that'll determine a little bit of how easily it'll melt. But how do we actually determine what type of rock is what? Well, felsic rocks are the light-colored rocks, and they're rich in elements such as aluminum, potassium, silicon, and sodium. And mafic rocks are dark-colored rocks, and they're rich in calcium, iron, and magnesium, but poor in silicon. The basic thing to remember is mafic rocks contain metals, and that's why they have that dark appearance. And if you're looking at a light-colored rock, it's felsic because it's missing those metals. And having metals inside of a rock actually lowers the melting point of that rock material, meaning that the lava that you have is going to be a runnier, more watery lava, and the lava of melted felsic rocks is going to be more viscous and flow like syrup, okay? And that determines what type of landforms will actually form from the cooled magma. So when we get into intrusive and extrusive here, you'll see how that plays out. All right, texture. Texture is referring to the grain size. So coarse-grained rocks take longer to cool, giving the mineral crystals more time to grow. So the identical molecules can find each other, they can pair up with each other and grow big crystals. But if it cooled off really quickly, then you're not going to have many crystals, or you won't have any at all if it cooled off really fast. And if it cooled off really, really, really fast, you can even get air bubbles in the rock itself because air gets trapped in there. So Here's a diagram where we see 4 different rocks, and the rocks on the bottom have something in common with each other, and the rocks on top have something in common. And the rocks on top are both felsic, and the rocks on the bottom are both mafic. But there's another way that we can categorize these rocks, and we can talk about their texture or their grain size. So we have coarse-grained rocks on the left and fine-grained rocks on the right. And the coarse-grained ones you can see have big crystals, and the fine-grained ones you can't see the crystals, but if you had a magnifying glass you'd be able to. All right, so what causes these differences in texture of igneous rocks? Well, intrusive igneous rocks are the ones that cool below the Earth's surface. And so that surface, the Earth there, is kind of functioning like a blanket, kind of insulating the rock, or insulating the magma so it cools off slowly. And if it cools off slowly, those crystals are going to grow, and you're going to have a coarse-grained rock. Extrusive rock erupts onto the surface as lava and then cools quickly, and you have very small crystals or no crystals at all. And so it's exposed to the air, the lava comes up out of the ground, it's exposed to the air really quickly, and it cools off really fast, and you end up with a rock that doesn't have very large crystals. All right, so here's an example of a rock. Obsidian is a dark-colored volcanic glass that forms from very rapid cooling of molten rock material. It cools so rapidly that crystals do not form. So, felsic or mafic? Well, we can tell by looking at the color that it's mafic. Fine-grained or coarse-grained? It is fine-grained or even no-grained because it cooled off very quickly and we don't see any of those big crystals. So is it intrusive or extrusive? It is extrusive. And volcanoes are a perfect example of an extrusive landform because the magma is coming right out onto the land. So volcanoes produce extrusive rock. All right, sedimentary rock, the other one of our big 3 categories. Sedimentary rocks are formed from erosion, and then the sediments move to another place, and then they're deposited in layers with the older ones on the bottom. The layers can be compacted and then cemented together. So that the erosion and the weathering, and then the compacting and cementing together, that is what makes something a sedimentary rock. So sedimentary rocks are made at the Earth's surface. There's no heat and pressure involved. Now when I say that, there is some pressure, but we just call it compacting. If I mention pressure in this unit, I'm talking about metamorphic rock, because we're talking about a much, much greater amount of pressure. We call the rock layers strata, and stratification is the process in which sediments get laid down in layers. So here's one example of a sedimentary rock, and this is the category of clastic sedimentary rocks, and we describe clastic sedimentary rocks by their grain size. All right, so this one's breccia, most often used, is a term often used for clastic sedimentary rocks composed of large angular fragments larger than 2 millimeters. Spaces between are filled with the matrix of the smaller particles or mineral cement that bonds the rocks together. So the stuff in between there is typically calcite or quartz that was dissolved, and then it works its way in there and holds it together. It's kind of like the dough in a chocolate chip cookie, and then the big angular fragments are like the chocolate chips. So clastic sedimentary rocks are always going to be made like this, where they have the big pieces and then they have small minerals that were dissolved, and then the water evaporated, and then it's holding it all together. The other category is organic, and organic rocks are always made from the remains of plants and animals. So coal is an example. It's basically made from old plants and old algae from the Carboniferous era, and it's used as a fossil fuel, but it is also an organic sedimentary rock because it was made from the remains of plants. If you have limestone that was made with shells, it's considered organic because it's made with the remains of animals. Lastly, we have chemical sedimentary rocks, and that happens whenever a chemical reaction happens in water, and the chemical reaction ends up producing a solid or something that cannot dissolve. So in the bottom animation, you see sodium hydroxide and silver nitrate. One of the products of that reaction is silver hydroxide, and the silver hydroxide does not dissolve in water. Oh, and then it'll eventually cluster up and form chemical limestone, which is what you see behind. Now, chemical limestone is not made from sodium hydroxide and silver nitrate, but this animation shows you what it looks like when a solid forms in a liquid. All right, lastly, metamorphic rock, meaning to change form. Metamorphic rock changes with temperature and pressure, but always remains solid. So you get more heat, more pressure, but you've never actually melted. Okay, it takes place deep within the earth. And there's two types of metamorphic rocks. They can form by what is known as contact metamorphism, which is basically when you're already deep underground, but you get heated by magma. So the contact metamorphic rocks, they do not melt, but they are next to molten rock that contains the heat. And so they're already deep underground, they have the pressure, they just need a little heat. And so what you end up with is metamorphic rock forming around that pool of magma underground. The other type is regional metamorphism, which is basically metamorphism that is caused by two tectonic plates pushing against each other. So large pieces of Earth's crust collide and the rock gets deformed and chemically changed by the heat and the pressure. So here you see two continental plates coming together, and here you see continental and oceanic plate coming together, and right where those wavy lines are where you're producing metamorphic rock. So we can describe metamorphic rocks as foliated or unfoliated, and it just has to do with the way that it looks. It doesn't actually tell you anything about whether it was contact or regional metamorphism that formed it. So foliated just means that there's these bands in the rock, and so you can see these white and black stripes running through this one. This is called a gneiss. It's foliated metamorphic rock. It has a banded appearance, made up of granular mineral grains, typically contains abundant amount of quartz and feldspar. And here we have a non-foliated rock, so you don't see any bands or sheets at all. This is marble. It's made from limestone that was then chemically changed by heat and pressure. So this used to be made of shells, or it used to be a chemical limestone, one of the two. All right, so which one of these is foliated? That one, phyllite on the far right-hand side. The other two are non-foliated. So you can see the phyllite has those bands in it. All right, so just to recap, the rock cycle, there's three main groups, and what determines what type of rock you are is the process that just happened to you. If you had just melted and refrozen, you are now an igneous rock. If you had just been ground up and weathered, and then you were compacted and cemented together, now you're a sedimentary rock. And if you were to be put under intense heat and pressure without melting, then you're a metamorphic rock. Whatever just happened is the type of rock that you are. All right, thank you for your attention.